Alright, so in this video we're going to talk about tax revenue problems. So sometimes governments, they levy taxes on goods produced. And these taxes get passed along to the consumer in the form of higher prices. All right, so let's draw a picture here. So we have supply and demand curves. Demand curves go down. Supply curves go up. And where they intersect, that's the equilibrium quantity and equilibrium price. So if the government levies a tax on the producers are going to pass that cost off to the consumers. And they're going to do that by just increasing the supply curve. So here's the old supply curve. They're just going to move the supply curve up the amount that they get taxed. And I'll call that amount T. All right, and in a competitive market, the consumer demand only depends on the price. So the consumer demand is still this same shape here. So this new supply curve is going to shift the equilibrium quantity lower. Because the price is higher, the consumers are going to buy less. Okay, let's write this down. So in a competitive market, the consumer demand depends only on the price. So they're going to buy less. They will buy less of the product as a result of this tax. The revenue that the government gets from this, the tax revenue, is the tax per item times the quantity, the equilibrium quantity. I.e. T is little t times Q. So if the tax is high, the Q will be low. The quantity Q will be low. And if the tax is low, the quantity Q will be close to what it was before. Let me sketch a few examples here. So say we have a really high tax. So here's the old supply. Here's the new supply. In this picture, the quantity is going to be quite small. This is the Q. And the shift up is going to be quite high. Okay? If, however, we raise the tax a medium amount, so here's the old supply, and maybe we raise it up to here. This is the new supply. Then the T is going to be that amount, and the Q is going to be this amount. That's the equilibrium quantity. And if we add just a very little amount of tax, well, we're not going to shift over much. So this is the tax increase right here. And this is the Q, the corresponding Q. So the tax revenue in each of these situations is the product of T times Q. So it's this area. This is the tax revenue. And so if we want to maximize tax revenue, we want to maximize this area. Okay, so the goal here is to maximize T, i.e. the most profitable trade-off between tax amount and the quantity that results. Okay, so let's work through an example. Call this example 1. So suppose the supply curve is P equals 2Q plus 10, and the demand curve is P equals negative 2.5 Q plus 640. And the question is, how much should the government tax each item to maximize their tax revenue? Okay, so we're going to do 3 steps. Step 1 is going to be add T to the supply, shift that supply up, and then set the supply equal to the demand and solve for T. Okay, that's step 1. Step 2 is find the tax revenue function. T is going to be the tax per item times the quantity, so little t times Q. And we want to maximize. We want to find the Q that maximizes T. Maximizes this revenue. And then step 3, we're going to find the tax amount corresponding to this Q. All right, so let's first add T to the supply and then set supply equal to demand. I'm going to make a little space here by moving this down, this next step down. Okay, there we go. So we're going to add T to the supply. So the supply is 2Q plus 10. My new supply post-taxation is 2Q plus 10 plus T. Going back to that picture from earlier, we've taken this supply curve and we've shifted it up T. Okay, then we set the supply equal to the demand. So supply equals demand. We get 2Q plus 10 plus T equals negative 2.5Q plus 640. That's our demand. And then we solve for T. T equals, subtracting 2Q from both sides, we get negative 4.5Q. And subtracting 10 from both sides, we get plus 630. Okay, so that's our tax as a function of Q. Okay, we're done with step 1. Now we want to find the tax revenue function. So we want to take our tax and we want to multiply it by Q to figure out how much money we make. All right, so big T is little t times Q, or negative 4.5Q plus 630 times Q. So negative 4.5Q squared plus 630Q. And we want to maximize this function. So we want to take the derivative and set it equal to 0. So we'll take the derivative, dt dq, is negative 9q, 2 comes down, makes 4.59, plus 630, the q becomes 1. And we want to set that equal to 0. So we have this revenue function, it's a quadratic, looks something like this. And we're trying to find the vertex. We want to find where the derivative, t prime, is 0. And if we solve for q here, we get we'll get negative 9q equals negative 630. So q is 630 divided by 9. So q is 70 units. That's the amount that will maximize our revenue. And now, in our last step, we want to find the tax amount corresponding to this number of units. So we have this t function from step 1. If we want to take our q and put it into the t function to find how much we should set our tax amount. So t is, copying it from above, negative 4.5q plus 630. So t with 70 units plugged into it is negative 4.5 times 70 plus 630. 70 times negative 4.5 is negative 315. So if we add 630 to negative 315, we get 315. And that's the tax amount that we should, or the government should, apply to each unit to maximize their revenue.